So how does the Pongo tree really work this way? Let's demonstrate using a simplified version of a tree. Basically, trees consist of trunk, branch, and branch gain, and of course, the leaves. Well, this is the secret sauce of all of it, the factor rotate. Let me explain. First, factor. Let's count numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Imagine this is a ruler. Let's count again, but this time with these dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Basically, the ruler tracks where the dots are being placed. Now let's add another ruler this way, with the same numbers. The dots are placed in this location. Basically, we say 1, 1, 2, 1, 3, 1, and so on. Congrats! Now you have 2D factor diagram. Let's add the negative ruler so you can place in the negative direction too. Add another ruler, and congrats! Now you just made 3D factor diagram. A factor basically is a placeholder to represent a point in space. Now, back to factor rotate. It's kinda obvious. It's for rotating a factor. There's the center, which basically tells the pivot point where you want to rotate around. If we put 0, 0, 0, basically the pivot starts here, which is the center origin of the world. If we put 1, 1, 1, the pivot goes here. Then the factor. It acts like an axle in the car wheel. So basically, which axis do you want to rotate? And last, the rotation degree itself. Now, let's put the scene time into the rotation. Basically, we have our factor rotating over time like clockwork. Now, just replace this factor, and you guess it, with the 3. So now, what if instead of rotating it over time, we want it to rotate back and forth like a pendulum? If you remember and studied math at 8th grade, that's what the sine function does. If we put scene time into sine function, now we have pendulum-like motion of our trees. If we want the sway to go faster, just multiply the scene time by some value. Now, it looks kind of static. How about when we go further to the tip of the branch, the factor rotation gets bigger? For that case, we can just use the factor and multiply it again. So, it will look like this. Do this to the leaves and also every hierarchy of the branches, and now you have the tree animation. I know this is not physically accurate, but with a bit of math, you can solve problems like this with a cheaper computational approach. Do you like this kind of video? Please let me know what kind of content you want me to break down in the comment section.